Hello everyone, welcome to the series of tips and tricks at Mathegination. Our today's question is about an exponential problem in which we are given an algebraic equation and we have to choose the value of x which satisfy this equation. Finding out the value of x is one problem, but finding out how many such values of x exist is actually a very mathematical analysis question. So let's first see how many x we have in this equation that satisfy this equation, and then by easy hit and trial you can find out the value of x which satisfy this equation. Okay, so let's see how we can find out how many solution this equation actually have. Before going to the solution, if you are new to our channel, please subscribe our channel so that you can learn more tips and tricks about mathematics. Okay, so the equation we are given 5 raised to the power x minus 3 raised to the power x equals 16. First thing, we have to divide this equation by 5 over x. Why we are dividing 5 over x, you can find out in a bit. So both sides I am dividing by 5 over x. So 5 over x, beneath it we have another 5 over x minus 3 raised to the power x divided by 5 over x, 5 raised to the power x equals 16 over 5 raised to the power x. Now this 5 raised to the power x, 5 raised to the power x cancel out. We actually got only 1 minus here we know that 3 upon 5 may come in the bracket and this x become the power of whole equals 16 upon 5 power x. Now 1 remains as it is on the left hand side. This 3 upon 5x come on the right hand side. It becomes 3 upon 5 raised to the power x plus 16 over 5 raised to the power x. Now we have to analyze these two terms, i.e. this right hand side. Okay, so here you can see that first term is our 3 on 5 raised to the power x, right? Since we know that 3 upon 5 is actually less than 1, right? 3 upon 5 is less than 1. And we know that if we have a function y, which is equals to some base with the power of variable, i.e. y equals bx. So here b is 3 upon 5, power is x, and b is less than 1 and greater than 0. So this implies that y is what? Decreasing, right? So y is decreasing function because whenever you are increasing the value of x, the value of y is decreasing because this b is less than 1. So actually you find out that if you draw, you can find out like this graph, right? So it means that this value is actually decreasing function whenever the value of x increase, right? After that, we have another value. Let's take this. So we have 5 over x. Now 5 over x, we know it is greater than 0, right? 5 over x is actually greater than 1 or equals to 1, you can say, because if x is 0, then so 5 over x is greater than equals to 1. It means that 5 raised to the power x is actually increasing function because whenever you are increasing the value of x, the power of x is increasing. And this is because we have this y equals b upon x. And if b is greater than equals 1, right? So it means y is increasing. Or if b is 1, so it's a constant. Y is increasing, right? So that's why we say, okay, 5 raised to the power x is increasing, but we have 16 upon 5x. 5 raised to the power, right? So this thing is decreasing because this thing is increasing and 16 upon something. So in denominator, something is increasing. It means this thing is also decreasing. So actually we find out that this term is decreasing and also this term is decreasing. It means this whole right hand side is decreasing function, right? And on the left hand side we have increasing function. So this equation we analyze it and we find out actually. So I write this equation like this in two parts. Let's say first part is our 3 upon 5 x plus, right, 16 upon 5 raised to the power. Okay, so this is one y. I am calling it y. The another, so this is our right hand side, and y equals 1. I am taking it as a function. So this is our left hand side. Now this is decreasing, right? And when x is 0, so when I am trying to find out the graph of it, so you can see if here in this equation, if you take x equals 0 and you put x equals to 0, so what you got? Y equals 3 upon 5 raised to the power 0, right? Plus 16 upon 5 raised to the power 0. So this thing is 1 plus this thing is 16 equals 17. So actually at x equals to 0, y is 17. And this is decreasing function. So it become like this. So actually the graph is like this. This is decreasing. So this is the graph of y equals 3 upon 5 x plus 16 upon 5x. And y equals to 1. So let's take this y equals 1, the value of y. So this, let's take it's this. So actually, this thing tell us that we have, since our equation is what? That 1 equals 3 upon 5 raised to the power x plus 16 upon 5x, right? This is our equation. It means we have to find the value of x in which this thing, left hand side and right hand side are equal. And this is the graph of left hand side, y equals 1. And this is the graph of right hand side, y equals 3 upon 5 raised to the power x plus 16 upon 5x. And both of them meet at only 1. So it means only one solution we have of the equation that we are given, right? So our equation has only one solution. So our equation 5 upon x minus 3 raised to the power x equals 16 only have one solution. So what this solution is, just you can find out by hit and trial, and the solution is really easy. Just put x equals 2, right? So 5 raised to the power 2 minus 3 raised to the power 2 equals 16. 5 raised to the power 2 is what? 25 minus 9, we know it is equals to 16. So actually x equals 2 is the answer. But most importantly, we know that after that there is no answer, because we find out that this equation has only one solution. I hope you enjoyed this video. If you like this video, please subscribe our channel. Until the next video, bye bye.